Alright guys, welcome to Math 0314, lesson 6.8, complex numbers. Today we're going to tackle the issue of if you have a square root inside, negative inside the square root. So the way mathematicians get around this is that we sit and we say the square root of -1 is I. So we just define the square root of -1 as I. So what I did just now, just to be super clear, is that -64 is the same thing as -1 times 64. And if we take the square root, well, we know we can partition the square roots into two separate parts, and the square root of -1 is I. So anytime you see a negative, you really can just almost just pop the negative on the outside and just play with the square root. So let's play with the square root of 50. So what you want to do is you want to break this down and take out a perfect square root. That would be 25. So this breaks down to 2 square root 25 square root 2. Then we know the square root of 25 is 5. So this is 5i square root 2. And that's my answer. So if you haven't done so already, go ahead, pause the video right now and try 3 and 4. Shouldn't take you more than a couple seconds to do these. Good, assume that you've done it. So we know that, again, I said a negative, you can pop an I out in front. Square root of 4, we know the square root of 4 is 2, so this is just 2i. Now, if it comes out nice, we usually write the number in front of the of I. And I almost said variable, but this is not a variable, right? This I is equal to the square root of -1. So, okay. Square root -29. Square root of 29 is actually prime, so we can't do anything with that. Just tack an I in front of it, and that's it. So hopefully that's not too bad. Let's look at the next situation. All right, so now we're dividing. You have two options here. You can divide the top and the bottom. So this would be, the top would be I times 10, or 10i, and the bottom would be I times 5, or 5i. So we have 10, I'm going to rewrite it as 10i over 5i. We know that the 5 goes into 10 two times, and the i's would divide out, so you're just left with 2. Or if you prefer, we can separate the into -100 over -25. We can put them together. If they're separated, we can put them together. And 100 divided by 25 is 4, or -100 divided by -25 is 4. The square root of 4 is 2. And you see we'll get the same answer either way. So kind of cool that you can jump back and forth between the two methods. Number 6, more of the same. If we want, we can say that this is going to become, this one here is just going to take the negative on the outside. So we have I, square root of 25 is 5. Same thing here, times I, the square root of 9 is 3. So this is just 5, oops. Mine goes faster than the hand. This is 5i times 3i. So 5 times 3 is 15. I times I is I squared. Now we know that I squared is -1, so this leaves me with -15. Now, you may be asking yourself, well, how do I know I squared is -1? Well, we know this because if I is the square root of -1, then I squared would be taking the square root and squaring it, and we know that when we square a square root, these go away and you're left with -1. Hence, I squared is -1. So hopefully that makes sense. Looking at the next one, you should pause the video now and try this. I'm sure you guys can do this on your own, but we'll do it together now. So this becomes I square root 5. The other one is the same exact thing, so it's I square root 5. So we end up getting I squared. I times I is I squared. Square root 5 times square root 5 is 5. So it's 5I squared. Again, we said I squared is -1, so this is 5 times -1, which is -5. Now comes an interesting part, which is we're asked to figure out what is I to the 13. Well, we were talking earlier, we said I equals the square root of -1, we know I squared is just negative 1, because it's the square root of negative 1 times the square root of negative 1, which is negative 1. So I cubed would thus be I squared times I. And we know that I squared is negative 1, so this just becomes negative 1 times I, or simply negative I. Piggybacking off of the other ones, I to the fourth is nothing more than I squared times I squared. If this isn't clear, right, with the first two, when the bases are the same, we add the exponents. So that's why I'm rewriting it squared and squared. We like this because we know I squared is negative 1 again. So we can just simply say that this is negative 1 times negative 1, which is 1. Now, getting 1 here is very, very, very profound, because what that means is that everything after I to the fourth is a repetition of this. So, for example, if I take I to the fifth, I know I to the fifth is I to the fourth times I. And the reason why I want to write it that way is we know I to the fourth is 1, so this is 1I, which is just I to the sixth, right, just to get the pattern going, is I to the fourth times I squared, which is 1 times I squared, which we know I squared is negative 1. So essentially what we have is we have sort of this becomes periodic. What I mean by that is it repeats every 4. Now, if you have something that's periodic, a nice little trick that you always want to do with something that's periodic is say, well, hey, look, I could actually just take 13 and divide by 4, which would give me 3 with a remainder of 1. Now, I like 3 remainder 1 because what 3 remainder 1 means is I cycle through this pattern here 3 times, and then the next time it's where I stop. And so because it's 1, I'm going to stop with I. So the answer here is that I to the 13 is just I. So this remainder tells you which one of these it becomes. Okay, so let's look at another one. Let's see if we can figure this out together in a more clear way. Okay, so what I'm arguing is that square root of I is I squared is negative 1, I cubed is negative I, and I to the fourth is, positive 1. And everything after that just repeats, right? Here's the proof for why what I just said is true. But if I know this, all you have to do is take 18, divide by 4, which gives me 16 remainder 2. The 2 says this is 1, this is 2. So the answer to this is the same thing as saying negative 1. That's all you have to do. Now, one thing I want to stress is that if the remainder is 0, there is no such thing when we solve problems to get when you divide to get a remainder of 0. Remainder of 4 if you're dividing by 4. So let's say something like 16, right? 16 divided by 4 is going to give me 4 with a remainder of 0. What this means is that the very last one is actually the case of remainder of 0. Because if you said that this was remainder 4, what you're really saying is 3 remainder 4, right? Which is the same thing as 4 is, the remainder of 4 is, if you're cutting it into 4s, is just 1, right? Another piece, right? Another way of thinking about this is let's do something like 7 divided by 4. What we're saying is when we cut it up, how many times can we cut it up in a circle into 4s if I have 7 pieces? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And so what that means, what this is saying is 1 piece with a remainder of 3, right? So if I said a remainder of 4, it would be the same thing as saying 2, right? If this was 4, it would be the same thing as saying remainder of 2. So hopefully that makes it a little sense in terms of what's going on here. Go ahead, pause the video and try this real fast. I'm going to assume that you've done so. So all I'm telling you to do is just take 107 divided by 4. We know that 4 goes into 10 2 times. It gives me 8. This becomes 27. This is 6 with a remainder of 3. So what this means now is that when I look over here, I'm going to go to the third one, which is negative I. And that's my response. Go ahead, if you haven't done so already, pause the video and try this one on your own. I'm going to assume that you've done so. So this one is the case that I had mentioned before. When you solve, we know that 4 goes in evenly into 32, goes in 8 times. It gives me a remainder of 0, which means it's going to be the last scenario, which is 1. So this is actually equal to 1. Okay. So you can see why hopefully you see why this works. How that all we're doing is we're cycling. Let me use this version because it's a little. Well, you know what? Actually, let me just rewrite it. I squared, I cubed, I to the 4th. And again, what I'm saying here is that after the 4th one, it goes back to the first one again, right? And repeats over and over and over again. Hopefully that's clear as to why. If you really panicked, you could write out this pattern 32 times, but by the time you get to the 32nd line, you probably would figure out what the pattern is. Okay, let's move on to more complicated things. This question is asking us to rewrite in A plus BI format, identifying both real and imaginary components. So when we say A plus BI, all this means is that this is the real number. So these are the numbers that we're used to. These are the numbers you've been playing with most of your life. And then we've introduced what's called the imaginary component. This is the imaginary number because it has an I attached to it. So the real number would be negative 8 for the first one, and the imaginary would be 2i. In B, realize that 3 over 2 is the same thing as 3 over 2 plus 0i. So if you don't have a real or imaginary component, you really do. It's just 0, right? So 3 over 2 is the real number, 0i is the imaginary. And C, it's the same thing, only on the back side. So 1.75, negative 1.75 is the imaginary, and 0 is the real. And number 13, they're asking us to simplify. So don't let this confuse you. When we're adding, it's pretty straightforward. We just combine like terms. So 1 and negative 3 is going to give me negative 2. And negative 5i and 7i is going to give me plus 2i. And there's my answer. In a situation like this, still not that complicated. We know that when we have an I, we can a negative in the square root, we can tack it on to the outside. The square root of 8, I'm going to break down to the square root of 4 times square root 2. And the square root of 18, I'm going to break down to 9 and 2. And so this breaks down to 2i square root 2 plus 3i square root 2. And there's my answer. And 15, this is where we start to get to the real interesting stuff. We're going to FOIL here. So foiling gives me 20 plus 30i minus 10i minus 15i squared. I squared is negative 1, which breaks down to plus 15. 30i minus 10i is 20i, and the front part is 20. And so as we continue, we can put 20 and 15 together, and we get 35. So we're left with 35 plus 20i. And there's my final answer. So you're essentially just foiling. The catch here is that we now know I squared is negative 1. So whereas, and this is normally actually on the front edge, but when it's on the back end, it doesn't matter. Position is not relevant. Then we just I squared is negative 1, so then we can just convert it to just 15, and then these two will combine because they're like terms to give me 35. So here they're trying to scare us by giving us decimals. There's a couple ways of approaching this. The way that I'm thinking is I actually don't like decimals at all. I'd rather write the problem out as a fraction instead of a decimal. And then I'm going to do something a little unconventional. I'm actually going to say, because these both, actually in both of them, are being divided by 10, we can factor out a 1/10. And we have 12 plus 5i, and do the same thing on the other side. So let me write it this way, 1 over 10, 12 minus 5i. So we can take the 1/10, we can combine those, and we get 1 over 100, and we're left with 12 plus 5i, and 12 minus 5i. The cool thing here is that these two, we have completing the square. So this is just 144 minus 25i, and then we have the 1 over 100 on the outside. So if you want to, you could distribute this 1 over 100 back in, and this would be 1.44 minus 0.25i. And that would be your final answer, where this is the real and this is the imaginary component. So I like that way. Some of you may just directly do it and not realize that because you jumped one here and you jumped one here. In this case, you have to jump back 2. And the same thing for 0.5 and 0.5 here, because you jumped 1 here and you jumped 1 here, you jump 2 back and you get 0.25. So, but let me rewrite just to be clear. Either way, this is your answer. Cool beans. All right. 17 and actually 18 are the last last situation we could see. In both of these situations, there is a new process where we call it multiplying by the conjugate. So the nice thing about multiplying, this is actually what we did here. If this was the term, we multiplied by this, which is the conjugate. We like that the conjugate is just, if you have a positive, then you would multiply by the negative. Because what we like to do is we don't like to have i's in the denominator. So the conjugate just says if you change the sign, you create the difference of squares. And I like that because when you have the difference of squares with imaginary components, you actually end up getting a whole, an integer on the denominator. So I'm going to leave the numerator alone for now. I'm just going to play with the denominator. So if I have the difference of squares, this is 25 minus 4i squared. We know I squared is negative 1, so we have 25 minus 4 times negative 1, which is 25 plus 4, which is 29. So this becomes 4 minus 3i, 5 minus 2i over 29. And now I'm going to FOIL. And so when I FOIL, I'm going to get 20 minus 8i minus 15i plus 6i squared all over 29. As I clean it up, I get 20. I'm going to go ahead and put these two together. This is going to become negative 23i plus 6 times negative 1 over 29. And so this becomes negative 6. 20 minus 6 is 14, minus 23i over 29. This is fine in my eyes, but a lot of times you're going to see that they write it as such. And the reason why they do this is the real and this is the imaginary component. So either way, it's correct. But the big deal is that when you're asked to simplify or put into real and imaginary, something where you divide, you have to multiply by the conjugate. Now keep in mind that if this problem was 4 minus 3i over 5 minus 2i, if we started off that way, this would be multiplied by 5 plus 2i on the top and the bottom. Okay? And the reason why is that the whole point is to create, right, the difference of squares. One other point that I want to stress here is that The reason why we do this is that you're not changing the problem, right? You're actually just multiplying 5 minus 2i over 5 minus 2i is 1. So when you're doing this, you're just multiplying through by 1 to make the and not changing the problem up at all. So this is very similar to when you try to find a common denominator. You might multiply, let's say you're trying to find 12 as the common denominator. You multiply one side of the fraction, the top and the bottom, by 4. Right, and the reason why we do this again is because this is 1 times 2/3, so I haven't changed the same thing actually as 2/3. So hopefully that didn't confuse you. This problem here is, honestly, this is just, we've got to break that down. So we know that, again, it has a negative, so it has an I. The square root of 18 is 9, is 9 times 2. Square root of 9 times the square root of 2. The square root of 9 is 3, so this is 6 plus 3i square root 2 over 9. We can reduce if we want to, that's fine, because they're all divisible by 3. So we'll say 2 plus I square root 2 over 3, which I can rewrite as 2/3 plus I square root 2 over 3. And there we have it. So, a lot to digest. I know this section's a little tough, but my advice to you is to, if you're struggling, to rewatch the videos and try to work the problems out as much as possible on your own. When you get stuck, look at what my work was and see if you can get down to the answer. But that's all I got for you now, so I will see you guys in the next video.